In this class, we are going to discuss about question number 20, exercise 14.1 probability. Observe this question. Suppose you drop a die at random on the rectangular region shown in figure. What is the probability that it will land inside the circle with diameter 1 meter? What we are doing, you drop a die at random on the rectangular region shown in a figure. We are having one rectangle. So what about its solution? Observe, given things I am writing, given length of rectangle L, length of rectangle L is what? Length of a rectangle. This is what? 3 meter. Breadth of rectangle equal to what? 2 meter. Another thing we are having, what? The circle with diameter 1 meter, in which we are having circle and its diameter is what? 1 meter. So radius of a circle R equal to what? L is what? L is this one, length of a what? Rectangle. And breadth, this is what? Breadth B equal to what? 2 meter, and its diameter is what? 1 meter. So radius will be what? Half of diameter upon 2. So diameter is 1 divided of 2. So radius of this circle will be what? 1 upon 2 meter. So these things we are having. What we are doing? You drop a die at random on the rectangular region. We are dropping what? A die at random on what? On the rectangular region shown in a figure. We are having one rectangular region in which what we are doing? We are dropping a die. What is the probability that it will land? It will land. What? Die will land. It will land inside the circular. We are dropping die. We want to probability that die will drop. What? Die will land inside the circle. Die will land inside this circle, and this circle having diameter 1 meter. So its radius is what? 1. Its radius is what? 1 by 2 meter. Clear? So we want what? Probability. What we want? Probability of the die land. Probability of the die land inside the circle. What? Observe carefully. This thing we want. What we want? Probability of the die land. We are dropping a die. Probability of the die land inside this circle. You drop a die at random on the rectangular region. We want what? Probability that die will land inside the circle. We want to probability that one. Probability of die land inside the circle. We know well, probability of an event equal to number of favorable outcomes divided of total possible outcomes. So I am writing formula: number of favorable outcomes divided of what? Total possible outcomes. This is the formula of probability. Number of favorable outcomes divided of total possible outcomes. Now in this case we are having what we are having? Total possible outcomes. We are having what? Area of rectangle. And number of favorable outcomes will be what? Area of circle. Observe carefully. What we are doing, we want what probability of die land inside the circle. Die land inside the circle. So number of favorable outcomes, we are dropping die inside the circle. So number of favorable outcomes will be what? This area. So number of favorable outcomes. Why we are selecting this one as a favorable? Because we are dropping. We want what? Probability of what we want? Probability of die will land inside the circle. This thing we want. So this is what? Favorable. So we can say number of favorable outcomes will be what? Area of a circle. Area of a circle divided of what? Area of total possible outcome. Area of a rectangle. Area of a rectangle. So area of a circle we know what? Pi r square. And area of a rectangle is what? Length into breadth. Area of a rectangle is what? Length into breadth. Now put the values. Pi into 1 upon 2. R is what? 1 upon 2 whole square divided of length into breadth. Length is 3 meter. Breadth is what? 2 meter. So 3 into 2. Solve this one. We are getting pi upon 1 square is 1, 2 square will be 4 into 3 to the 6. So finally we are getting pi upon 6 4 is 24. So pi upon 24 will be what? Probability. This is the probability of die land inside the circle. So this is required answer. Observe again what we are doing in this question. Observe, we are dropping a die. What we are doing? We are dropping a die at random on the rectangular region shown in a figure. Dropping a die on the rectangular region. Now we want what? What is the probability of that? It will. Die will land inside. Die will land inside the circle. We want what? Probability of die will land inside the circle. It means probability of die land inside the circle will be what? Number of favorable outcomes, or in this case number of favorable outcomes will be what? Area of a circle. Clear? Because we want probability of die land inside the circle. So number of favorable outcomes will be what? Area of a circle divided of total possible outcomes. Total possible outcomes will be what? Area of a rectangle. We know both the formula and we will use this formula and we will put the values and solve. Then we are getting pi upon 24 will be what? Required answer for this question. So probability of the die land inside the circle will be what? Pi upon 24. I hope you understand this question. That's all about this question. Thank you so much.